In this video, I'm going to go over how to determine if an alkene is in the E or Z configuration. So here we have an example of an alkene where we have a double bond between this carbon and this carbon over here. So the very first step that I like to do is that I like to make a line directly through the double bond right here. And then after that, I like to look at one of the carbons of the double bond, which let's say we look at the left carbon first. And then we have to look at the atoms directly attached to this carbon here, besides the other carbon of the double bond. So here we see that we have a chlorine attached to this carbon and a carbon attached to that chlorine. To determine which one is a higher priority group, we have to look at the atomic number. On the periodic table, we know that chlorine has a higher atomic number than carbon does, which makes chlorine our higher priority group for this carbon here. So now let's move on to the next carbon of the alkene, which is the right carbon. Then we have to determine the atomic number between bromine and hydrogen. We know bromine has a higher atomic number than hydrogen does, which makes this bromine the higher priority group of this carbon over here. We see that the two highest priority groups are on the opposite sides of the line from each other, making this the E alkene. So for our next problem here, we have another alkene where we are going to determine if this has a configuration of E or Z. The very first thing that I like to do is make a line through this double bond right there. We focus on only one carbon of the double bond for now, which let's say we're going to focus on this carbon. We are going to determine the atomic number between bromine and hydrogen. We see that bromine has a higher atomic number than hydrogen, making this bromine the higher priority group. Now let's focus on the other carbon of the double bond, which is this carbon over here. Now we have to determine which atom has a higher atomic number. Would it be this chlorine or this carbon over here? If you look at the periodic table, we know that chlorine has a higher atomic number than carbon does, making this chlorine group the higher priority group. We see that the two highest priority groups of this alkene are on the same side of the line, making this the Z configuration. Now let's go over the next problem here where we have an alkene and we are going to determine if this alkene has a E or Z configuration. So let's do the same first step. We make a line right through that double bond right there, and then let's focus on one of the carbons of the double bond. Let's say this carbon first. We see that the atom directly attached to that carbon, besides the other carbon of the double bond, is another carbon and a chlorine. Looking at the periodic table, we know that chlorine has a higher atomic number than carbon does, making this the higher priority group. Now let's look at the next atom of the double bond. We see that this carbon here is attached to a carbon and a carbon. Since they have the same atomic numbers because they are the same atom, we have to look at the atoms attached to these carbons here. This carbon here is attached to one carbon and two hydrogens. We are counting the atoms that are not the carbon of the double bond. So here, this carbon here is attached to one carbon over here, and the two invisible implied hydrogens over here. Whereas this carbon here is attached to two carbons and one invisible hydrogen there. So we see that these carbons are the same, having the same atomic number, but this carbon here has a higher atomic number than hydrogen, making this whole group the higher priority group than this group over here. So we see that the two highest priority groups of this alkene are on opposite sides of the line of each other, making this the E alkene.